Aim of this lecture is to understand the steps in order to solve such question where it is asked that how to simplify Boolean expression which are not in canonical form using KMAP. So, in our previous lectures, we have only studied the or simplified the expressions, Boolean expressions, which are in canonical form. Canonical form means all the terms, if it is in SOP, sum of product form, all the terms have all the literals A, B, C, D, right? So you can write it in terms of min, summation of min terms. But there are situations where the Boolean expressions given to you might not be in canonical form. It is in standard form. So if you remember, in our previous discussion, I told you that we have two forms, canonical forms and standard form. So if you are writing any Boolean expression in sum of product form, it can be either canonical means each term has all the min terms, all the literals. So you can write it in sum of min terms form, or it can be in standard form. So in order to solve such expressions, either you can first convert it to, this is in standard form, right? This is in standard form, not in canonical form, this expression. So either you first convert it to canonical form and then you solve it using KMAP. But there is one more way that you can directly fill these because your aim is to represent this KMAP, this expression using KMAP, right? How can we represent this expression using KMAP without going through the procedure that we convert it to canonical form and then we fill the ones and then we simplify. So for this, what we have to see, we have to use this table, this logic. You remember that I told you that if you have a four variable Boolean expression, one square of this K map would correspond to a term which is of four literals, two squares would correspond to a term which is of three literals, four square would correspond to a term of two literals, and eight square, the square of eight small squares would correspond to one variable. So here it is written A prime B C. So we need to first see that where we can find A prime B, A prime B. So this whole row corresponds to A prime B. Then we have to see C, where C is 1. So A prime B, this whole term, and C is 1 here. So we should write 1 in these boxes. So this box together, this combined box would represent A prime BC, and you can see that two squares correspond to three literals, and we are taking two squares, and it corresponds to three literals. Now we have to see where should I put 1 in order to represent the term AB. So AB, for AB, we'll see this whole row corresponds to AB. So we will fill 1 to this whole row. And this will give you AB. And this also satisfies this. Check. I have just written check so that you know that AB, there are two literals and it would give you, these two literals will be represented by four squares. So these are the four squares which represent AB. In order to represent C prime D, you have to find out that this is your C prime D, right? This row, this column, C prime, this column is C prime D, this C prime D. We just fill 1 in this column. This one is already written here, so there is no need to write one more time. So we can see that this term, this SOP form in and this SOP in standard form is nothing but 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So You can see that you can also write it in the canonical form by just once you have represented this Boolean expression in Kmap, this 1, 5, 6, 9, 6, 4, 5, 6, 7, 1, 5, 6, 7, 9, 12, 13, 14, 15. This will give you the same expression in sum of in canonical form. But our aim is to next simplify this, right? So in order to simplify this, we have to do the grouping. So it is easily visible to us that we can group these ones like this. First one, and then we can make a grouping of these ones, and then we can make a grouping of these ones. So after simplification, we can see that this square will give you. Here we see that b is not changing, b is same as b, and c is not changing, and it is as c. So this square corresponds to bc. Next, this is same as ab, and this is same as c prime d. So simplified version would be bc ab plus c prime d. So it is not always uh, true that you have the Boolean expression in canonical form, that you can write it in the sum of min terms form, but it is in some standard form where each term does not contain all the literals. So this is how you can represent the Boolean function in standard form. Of course, it is in SOP, sum of product form, but not each term contains all the literals. So this is how you first represent it, and then you solve it. We solve it using the concept of looping, and so this is the simplified version of our expression. So similarly, you can take many examples. And you can try solving this question by using all the steps which we have discussed just now.